circles are just triangles in disguise. Trust me on that. Hey guys, today is a slightly different video because, well, we're going to go all the way to high school and some maths problems to actually prove a point that circles are just really triangles. And what I'm going to use for that is a Raspberry Pi Pico Kit that I've been sent from GeekPi. I know some of you are going to start shouting at me really loudly right now if I'm going to say that recently Micropython got a little bit more popularity thanks to a Raspberry Pi Pico development board. And I know it's been used on ESP devices before, but let's face it, if you're going to slap Raspberry Pi logo on something, the board's going to get access instantly to millions of users. And since I've got more than one of these, it's only fair I'm going to start using them for something so people that can't get a hold of it wouldn't feel that bad. So the kit from GeekPi I've received, I'm going to list in the description of this video. But first, let's open up the box and actually see what's inside and what you are getting for your money. Personally, I like the idea of having a kit because it will give you a bit of a guidance to what to do with individual modules, not just plain instructions to how to hook it up and how to run some code. I mean, that's at least the theory, right? So inside the GeekPi kit, you have lots of different modules to play with and the Raspberry Pi Pico that you can, connect to it. When I firstly opened the instruction manual or the booklet, I was pleasantly surprised with the level of details about modules and sensors and how they work. Unfortunately, that quickly turned into a very dry instructions how to hook them up and no explanation whatsoever what the underlying code supposed to do and what are small different parts of the codes are meaning. That means that the kit isn't really addressed to someone that's just new to programming. You have to have a bit of an idea how Micropython works in order to jump into it, analyze the code and start playing with it. And I think this is my biggest issue with the kit itself. I mean, we have a code examples, we have some libraries that support those modules, and we have a really nice explanation how the modules work, but there isn't enough essence to each project that gives you kind of sense of understanding what you're doing. You are left with it on your own. From interesting things inside, there is this breakup board that accommodates Raspberry Pico development board. It breaks out all the GPIOs, provides you with extra pins, buttons, buzzers and rails to supply power to your project. It has a space for a small prototyping breadboard that you can use to start your projects. Also inside you'll find small modules including OLED and LCD displays, servo and stepper motors boards and motors itself, and also array of sensors including photosensors, sonic sensors and other boards useful in trying things out. All of that is accompanied by obviously the cables they can use to connect things and some LEDs. And a quick tip, if your buzzer is going off during prototyping, there is a buzzer pin on the board connected to ground and that will shut it up. From the project library, there were two projects that I got interested in. One, project number 5 was using OLED display and MPU 6050 to display a date on an OLED display that moves according to accelerometer. And project number 10, which also uses LED and showcases how to drive the LEDs. So I decided to combine them and create a neopixel ring that's actually going to work like a level. So it's going to indicate the direction of the tilt. But in order to achieve that, we actually have to do some homework, and I'll tell you why circles are actually triangles. First, we need a circle. Well, I've got one in here and it's quite easy to use because it will reflect what are we going to do. If you draw it like that and imagine different LEDs being assigned to different locations on the graph itself, then you'll have a pretty much a good illustration of what's going to happen and where is the triangle. As you can see, in each section I can have 4 different LEDs corresponding to different angles. These LEDs are angled every 22.5 degrees, a number that's going to be useful in a bit. When the MPU 6050 is tilted, it'll give us a roll and pitch. Those two values that can be different, and they will span between -5 and +5. Plotted on the graph, it will give us a right angle triangle where the radius of that tilt, it's going to be basically our strength of the vector. And if the memory is serving you well right now, you probably recognize the Pythagoras theorem that I wrote down. This is how we can use the roll and pitch to calculate the strength of our tilt. Now that we have this, we can use that value to either change the brightness or color of the LED. So how about the information which LED we should light up? Now a tangent of the alpha angle is x by y, or roll by pitch in my example. To get the useful information out of it, we have to calculate the inverse tangent of the angle alpha, which basically gonna be given to us in radians, which you can easily calculate into a proper angle. And remember that angle value between individual LEDs, 22.5 degrees. Yeah, that's how you calculate which pixel you should light up. Okay, so we know the basic right now, so let's set up our main script. Now, went into the project 5 and basically got rid of every relevant data line that was related to the driving of the display. I'm not going to use it, but what I'm going to use is this. So this is all the libraries that are responsible for driving the MPU 6050. So I'm just going to copy this, paste it here. Now, I'm still going to need probably some of the supporting libraries for my LEDs, so I'm just going to head to project 10 and just quickly copy them here. I'm just going to paste it, and you'll see some of them are quite similar or the same, so I don't need twice this. We have a sleep. We also don't need a display. Get rid of that. Math, time, array time, times twice. We don't need that. That's great, and RP2. Okay, now that we have all the libraries prepared, we can do exactly the same with the project 10 when we're gonna take a look what's needed. Now, it's clear that we're gonna need a configuration for my LED, so let's grab that really quickly. And we have a configuration here, so... Well, I didn't quite get rid of everything. I need to get rid of this because this is for driving the display. So I'm just going to paste this, and I don't need this one because this is also to drive the display. Great. And I'm going to move this, keep it together. Okay, so this all basically allows us to drive our MPU 6050, and this is our configuration for LEDs. Anything else that I should be checking? No, everything looks all right. Okay, let's jump back to the LED and see what else is useful. Now, this is assembly code. I don't really understand the assembly code as such. However, I know that this is going to be needed to actually drive your LEDs. So this is just a library code that is being used to create the PWM signal and send the correct message from your Pico. So we obviously going to need that. So let's paste it in here. Great, and also we're gonna need some functions. Now, if you take a look at that example, it has a couple of useful functions. Now, first one is the show pixels. So this is what you're gonna use to actually display the color. So we're definitely going to need that. Now, another function that we're gonna need is pixel set. This allows us to set individual pixel to a certain color. Oops, let's fix the formatting. And also I'm going to need the same thing for pixel fill, which allows us to set the pixel, all pixels to the same color. Great, okay. Now that I have basics, we can actually start programming. Let's jump into our loop, and in here we're not going to have to touch anything. Now, what's the most important bit is the roll and pitch, and those are values from -5 to 5, and they correspond to the values you've seen on the graph. I'm going to print them. I'm going to move to providing us with some context. Now we need to define the angle strength. Now the angle strength, obviously, it's going to be that vector I've noticed. And this vector, basically, as I said, it's going to be our root square of pitch and roll squared. So it looks like that, right? We have our roll squared, we have our pitch squared, and all of that, we're going to have a square root of that. Now, because it's a strength, we are not concerned about positive and negatives values. So what we can do, we can actually use a math function fabs, which is basically a digit absolute, to get that as an absolute value, so from 0 to 5. And this value we probably want to also translate into something that our system gonna understand. Now if you scroll up and look at the display function, it uses the brightness in here for red, green and blue, and that brightness is from 0 to 1. However, our value in here is going to be from 0 to 5, so we have to do something about it. Now we can write a very simple convert function, which basically going to do that. It's going to map the pixels for us correctly, or the values correctly. So it will take our current value, it will take minimum in, minimum out, and what we expect to get out minimum and out maximum. That way we can simply just specify that, right? So we're gonna go back in here, wrap it in brackets so we don't get lost, or front bracket first. So convert, and now this is our x, right? Now our minimum value from this range is 0, our maximum value is 5. Now we want a value between 0 and 1. Sorted. Okay, so now that we have this converted, we can also make sure that this value never goes over 1, just in case. And to achieve that, you simply wrap it in another bracket, type in minimum. So we want this to be minimum value. Okay, 1. So we don't want that value to be bigger than 1. And we've got ourselves a nice, neat function here. Next up, we need to figure out which pixel we're going to light up when we're tilting it. So let's define our pixel. So we know from our graphs that we can use the inverse tangent between roll and the pitch. So this is our inverse tangent between the roll and the pitch, and this is in radians. So we have to actually calculate this into degrees. To do it, there's a math function in Python, or simply math.degrees, and that will give you a value in degrees. Now that we have this value in degrees, we can divide it by 22.5, which will give us an estimate or approximation of which pixel we have to light up. Since we actually need a whole number, we need to round this. So if we're going to go in here and we're going to use math, so that's going to round the number to nearest integer and makes us really, really happy. Now, this is a bit of a hack because right now, if you're going to start using it, you'll notice that these values in the pixels, they're going to span from -8 to 8. And this actually works because of Python. So if the span from -8 to 8 is still 16, and when we're going to be iterating through that, you'll light up correct pixels. So I actually don't have to change it. What I do have to change is define behavior of my pixel show. So if you're gonna scroll up back to here, you'll see that when we are showing the pixels, we use the brightness. Now we wanted that LED to basically indicate the brighter it is, or change the color based on the strength of that tilt. And we can achieve this by changing that to angle of strength, because this is value between 1 and 0 and 1. Now, if you want that, if you want this to be white, then you have to substitute everywhere. But I'm gonna keep it slightly blue or red, turning from red to blue, and I'm just going to simply fix the blue and green values to certain conditions. So only this one, only the intensity of red is going to change, and that way we're going to transition from red to blue. Now lastly, there's one more thing that we're going to need, because we're going to set some colors. So to set some colors, I picked 3 different colors. So in here, we're just going to go to setup, where's the LEDs, and I define purple, white and black as 3 RGB values. Let's write our logic. Now, we know that we're going to be checking our, if you want to test these values, obviously you can print, and then you can print pixel, which will show you which pixel you're going to light up, and angle strength. I'm going to spell it wrongly, so I'm just going to copy it. If you want, I'm not going to need it because I already tested it, but I'm going to leave it there for you. So we know if our angle strength is smaller than, let's say, 0.1 for the beginning. So this indicates that our board is flat, laying flat. Then what we want to do, we have a function in here that's going to basically fill all the colors. Okay, so we're going to use the pixel fills. Pixels fill, and we're going to fill it with purple. And then we're going to show it. Great, right? So if the conditions change and the angle is bigger than 0.1, then first we want to cancel all the pixels, or we only want to display 1 pixel, so we have to set all pixels black, and we're going to do that by sending a black to everything. And then we're going to use pixel set, which took a pixel and the color. So if you remember this, a pixel set, I'm going to use this here. And in this case, I'm going to set it to white. The color the initial color is going to be obviously that both colors going to be white, and then the red's going to have its transition based on angle strength. And done, guys, we sorted. Let's push it to my Pico. If you save it as main PY, that's going to run as a default program. If you save it as anything else, you'll have to run it. So I'm going to run it manually because I already have a main PY. And let's run the script. Okay, there is a small problem in line 2. It's probably some reference to something that we don't need. We don't need this. Is it correct? Yeah, we don't need this. Well, I thought I've deleted it. Okay, that's fine. Okay, let's try that again. Line 43. So see what it doesn't like on line 43. Array isn't defined. Interesting. I must have delayed the array end time. Obviously, we need those two. Okay, and then fix line 114 because about typo. Pixels, fill, and we don't need this. Great. Anything else? All right, we are sorted. If you don't believe me, we can start printing the values. So let's print the values. And as I move my board, different pixels and different values changes. So you can see those are pixels, and they will be positive or negative values, but because of the Python, it will sort itself out and it will display the data correctly. I have to say I'm slightly rusty, however I had plenty of good time trying to figure things out, read more about the stuff I used to learn in a high school, and kind of use it in a more meaningful way. I mean, back in the day, all that calculations were done on the paper and had no material context. If you were lucky enough to study in the field and use that knowledge into some practical applications, then great, but I couldn't be further away from it. So each time I've got an opportunity to do something like that, it makes me happy internally. So if you want to try it for yourself, in the description of this video, you're gonna find a link to an article explaining a little bit more about what just happened there and how I made that. LED work. Now that's gonna also contain the sample of the code that you can use in your project, and obviously the link to the kits itself that you can purchase online. We come to this part of the video and I say that I do not have a posting schedule, unfortunately, so if you want to keep in touch and find out what's next, then well, you know how YouTube works. I'm not going to teach you that. I've got a couple of social media that you probably want to follow if you want to start a conversation with me, and YouTube heavily moderates the comment sections without my knowledge, and I can't restore those, especially if they have interesting links. So if that's the thing, you've got something interesting to share, I would strongly recommend you to post it on my social media and start a conversation going. As for now, guys, thanks so much for watching, and I'll see you in the next video. Take care. Bye.